Yeah, hello everybody. My name is Benjamin Hert from Fraunhofer Institute for Cognitive Systems in Munich. I'm going to briefly introduce our work on evidence-based safety argumentation. So we've heard about this AI safety gap dilemma quite a bit today, so you all know it. We want to, on the one hand side, we want to leverage the power of AI for the development of automated driving functions. On the other hand, we have to make sure the system that we build is safe, and we have to demonstrate that the system is safe. And we all know this is a challenge. There are lots of uncertainties associated with machine learning in particular, and a rigid V-model-based process is just not working in that case. So we need a continuous assurance process that allows us to reduce our uncertainties and increase our confidence continuously over time. And we've heard about that today as well. There is no lack of data, there is no lack of testing results, simulation results, verification results. The challenge here is really to how to put all that information into some kind of line of argumentation that helps us to argue that the resulting system is safe. And at IKS, we're doing a lot of work on continuous safety assurance and on different building blocks. And one of these building blocks is the argumentation side of things, which I briefly talk about today. So the question is really, how can you bridge this gap between all the data that we have on the component level and this, the safety case on the system level? How can you argue about your system? How can you develop trust in your argumentation? And how can you make sure you argue that your system is safe and especially remains safe over time? So evidence-based safety argumentation, what is it? Very briefly, in a nutshell, the core of it is a structured argument, a structured safety argument. So we deliberately move away from pure document-based safety cases. So the structured argument is really some kind of semi-formal representation of the logical argument that you make to convince someone of the system safety. There are claims, subclaims, everything is underpinned by evidence, qualitative or quantitative evidence. The argument has to be logically valid and sound. So logically valid, it needs to be based on a solid reasoning process, and this reasoning process comes from a decent understanding of the causal relationships underneath. So what are the triggering conditions, what are the insufficiencies in the AI, what are the potential risks, and how are all these related? And that is reflected, that is reflected in the structure of the argument. We also acknowledge in this argumentation approach that we cannot anticipate everything at design time, so there are things we just don't know, there are uncertainties we can only resolve or mitigate at runtime, so we build explicit runtime placeholders for runtime evidence into the argument that we can feed into the argument during operation. And we also take into account the fact that some of the reasoning that we develop at design time might be invalidated during operation because of things that we didn't anticipate. So we build defeaters into our argument as well that we can underpin with runtime evidence, for example. This turns the safety case into a dynamic thing, into a dynamic structure that keeps being updated and keeps being continuously re-evaluated. And another important point is what we see at the bottom, quantify confidence metrics. So we have an approach built into this methodology that allows us to quantify our confidence in the safety argument. It's based on a mathematical framework, so we can take our safety case and from the bottom up develop or identify quantitative confidence values and propagate them up through the safety case. So we have an assessment how much we can trust the argument and how much we have to change it to push it above a certain safety threshold, for example. It is a semi-formal approach, so it's based on mathematical foundations, but it is semi-formal in a way that it also allows for subjective judgment. And this turns, as I said, the safety case into a living thing. into something that is developed at design time, but continuously being updated throughout the whole life cycle. It is reassessed continuously and in terms of confidence, and this allows you to react to potential unforeseen consequences. Thank you very much. It was very quick, but I hope I could convey the message. If you're interested, we have a booth outside. Please come and visit us. Thank you.
Thank you very much. Thank you very much. Thank you.